Okay, welcome everyone. Today we have Dr. Forrest Shull from the Software Engineering Institute in Pittsburgh. SEI, if you don't know about it, is a part of CMU. It's funded by the Department of Defense. It's a large place. Its main focus is research. They do lots of interesting stuff with large organizations like NASA, DoD, Fujitsu, what else? I mean, I don't know, Motorola. Do you work with Motorola? Okay,
Not currently, not at the moment.
A lot of large government organizations in particular. So Forrest is at SEI, heading the Empirical Software Engineering Research Initiative as an assistant director. Before joining SEI, he was a director of measurement program at the Fraunhofer Institute for Experimental Software Engineering at the University of Maryland. He was there for a long time. He is the current editor-in-chief emeritus of IEEE Software. He's the former editor-in-chief of IEEE Software. We worked and known each other for a very long time. That's why I don't need a actually index card or anything like that. Also, there are lots of software management students I see here, and then somebody was talking about GQM before, so goal question metric. So Forrest's PhD supervisor is actually happens to be the inventor of GQM, Vic Basili. So for your information, you may ask GQM questions as well. Anything else that I missed? His main interest is actually data-intensive techniques for evaluating software engineering techniques and practices. And he's done a lot of very interesting work in the measurement, defect prediction, empirical investigation of software practices, all of these areas in the past. And today he's going to talk about technical debt.
Thank you. I think I have. Can you hear me okay? Okay, great. So first off, thank you all for coming. This is a really lovely way to end up what I'm sure was a long afternoon for all of you. So I'm really happy to see you all here. And I love to be back in Mountain View, and I'm happy to have this opportunity to tell you about technical debt. This is what the lawyers make us say, so that's there. What I wanted to talk about today is, first off, if you're familiar with the literature, technical debt is getting a lot of play, both in the research, and it's a term that really resonates with practitioners, is one of the things we find. So that it's, I see it all the time in the literature, and that's only been increasing. And one of the things we see is that it ends up being used to cover a multitude of different topics. So one of the things I wanted to start off with by at least giving you our perspective on what technical debt is and isn't. How do we make it tractable so that we can actually get some value out of trying to manage the thing. I'll show you how we think about technical debt. And then the real results part of the talk, one thing is I want to show you the results of a survey we did of over 1,800 software developers talking about how technical debt really shows up in practice in the software development field. And there's some interesting insights there, again, as to what this really means in the day-to-day activities. And then finally, as Hakan said, I tend to be a very data-driven fellow myself. And so I'll end up showing you some of the data we've collected about whether we can show statistically that technical debt actually makes a difference if we pay attention to it and trying to manage it. So that's where we're going to go today. And if you're not familiar with the term technical debt, I wanted to start off by saying what is it really? And the interesting thing about it, I think, is that it's essentially a metaphor. So it all comes, this whole little area of study comes out of a kind of a throwaway line in a way that Ward Cunningham had back in '92, where he said, when I ship code, it's almost like I go into debt in the sense that I know I do some bad things. I probably cut some corners to make that delivery date. And cutting those corners is like taking on a little bit of debt. Okay? So that's fine. I can take on debt for good things. If anyone who has a mortgage knows you took on debt for the very positive thing of owning your own house. So there's positive things that going into debt allows us to do. And the bad thing is if I never pay it back, then I have an interest payment. And in the metaphor, the interest that I'm paying on some of these shortcuts I take is my velocity goes down. I have all these little shortcuts in the code. It gets more fragile. It gets harder to make changes to it. It gets harder for anyone new to come onto the team. So there's a very real cost that I pay for having these things out there. And the beauty of the technical debt metaphor is, let's talk about now, there's some good things I get out of these shortcuts, and there's some long-term bad things. And how can I start to get my arms around where do I cross the line? At what point do I say, okay, doing that shortcut got me something positive, but now I want to think about investing and paying off the loan, if I can push the metaphor to the breaking point, if you will. And as Hakan said, we were talking a little bit before the talk about GQM and having measures that connect to a goal in a lot of ways. And as he said, I've worked with Vic Basili long enough to know I'll never be free of GQM. It's really the way that I kind of look at the universe these days. And what I wanted to say there was the nice thing about technical debt is that so much of the work that we've done in the research community, I think, has really focused on counting the defects. And if my goal is to get a sense of the software quality or get a sense of is the software ready to ship, knowing how many defects are out there is probably a pretty good indicator in many cases. Okay? But not every defect is created useful. And I think one of the bad things that the research community has gotten into is kind of just counting defects as if they're all equally bad. Technical debt puts us back in this idea where I can talk about trade-offs now. So some of these shortcuts aren't necessarily just, it wasn't because I was sloppy as a developer, it wasn't because I was malicious, but it got me some short-term benefit. And I want to recognize that benefit before I start castigating myself too much for having took the shortcut in the first place. Okay. The other definition that we often go to is McConnell's 2007 definition, where he says, it really kind of puts that trade-off right up front and center. The idea of technical debt being when I do something that's expedient in the short term, but increases complexity and it's more costly in the long term. And so I have to pay off the short-term benefit and the longer-term pain if I don't pay back the interest. Okay. So this is a very nice conceptual definition. I think it resonates with a lot of people. I often like to use the next slide because it says, well, do I have technical debt in my system? Have I seen technical debt and not realized it? And we've kind of collected a lot of the indicators that tend to be out there on real software projects. So people that say, well, don't worry about the documentation for now. Or I have a piece of code and the only person that can change it is Carl. No one, it's so fragile and it's so mysterious, no one else really knows what was going on in there. So one of the shortcuts might be that I have this very dense code that's, I've never bothered to make it explanatory or something that's commented so that other people could come in and pick it up. The famous one, it's okay for now. I did a kludge to get me there, and we'll refactor it later. And the question is, does later ever come? And in many cases, no, not so much. Okay. Kind of similarly, maybe we're all familiar with code that has these kind of things in it that say, this is something that needs to be fixed. Fix this before we ever ship it. And you see these things there kind of maybe decades on after the code base is long mature. So an indicator of some technical debt that somebody meant to pay back at some point and never did actually get paid back. Things like, let's just copy and paste this part, it'll be good enough for now. There could be process debt too, in a way, if you stretch the metaphor. So does anyone know where we have the database access password? We've been relying on this other component. No one actually knows how to get into it anymore, but it's working well enough for now, and that's all that we cared about at the time. I know that if I touch that code, everything else breaks. I got it. It's running. That's all I care about. Don't worry about maintenance or anyone else ever coming in and modifying it, and so on. Let's push off testing. We'll finish it later. The release is coming up, so let's get it done. I think from the smiles and the nods around the room, these are things that most people have seen some version of at some point in their careers. And one of the reasons I like to put this up there is, again, just to say that technical debt isn't really some abstract metaphor, but it's something that we're all out there touching on a day-to-day basis. So what can we do about it? The other thing I like to point out, as Hakan said, the SEI where I work is a part of CMU that's funded by the Defense Department. And so we tend to work on things that the Defense Department cares about getting answers to. If you're at all familiar with the Department of Defense, you might know that the DoD doesn't really build much software these days. A lot of what it does is contract out to the private sector. DoD gives you the spec, you create the code to the spec, and it comes back into the DoD after that. So why do they care about it? Well, of course, the contractors that are building these systems for the DoD are creating debt just like any other developer. So we might have a timeline where the contractor puts some debt into the system. I recognize at some point I cut a corner there. I really need to go back and fix it. There's some optimal time when I could have refactored it that passes. I probably don't get to it. And then at some point off in the future, we hand the whole thing over to the government, who's now the proud owner of the system with all the debt in it. So that's fine for the contractor. We got our paycheck. We handed the thing off. It does what DoD needs it to. But what DoD now has is a system where we don't have very much insight into, is this going to be a painful thing to maintain? Is this a wonderfully structured code? All I know is that the behavior of it performs the spec. Okay. So really what we'd love to do is get to a point where this becomes a part of the management process in a very explicit way. That is, I can kind of hand it off, and the DoD, as they take receivership of the software, has a sense of how much debt is buried in there. You know, is this thing that I just took on, is this a ticking time bomb? Should I never touch it again? Or am I going to be able to go and add new capabilities to it as the need arises? Because the need always does arise somehow. Okay. And then just to give a sense, some of the surveys that we've done have been explicitly with the government side of things. And you can see here, you know, the government folks have this problem all the time, where the contractor developed the software, handed it over. Now I have a million lines of code that I didn't develop myself personally. No one on my team did. And we have to keep this thing up to date. We have to add new capabilities. How do I do that? I would love to know when I take it on how much data I'm actually getting, along with the working capabilities. And so that's kind of what focuses our work. You know, we're working both with DoD and industry because everyone manages or struggles to manage technical debt. You know, balancing these trade-offs. One of the things that one of our kind of overriding goals for this work is to get technical debt kind of at the level where I would manage it the same way as defects. So there's a lot of cases right now where I make these shortcuts. I don't even recognize it some of the time. And if I do, I have nowhere to record it. You know, it typically doesn't go on my defect tracker list in the same way as, you know, a real defect that's found in inspection or testing. But we would love to get it to that point. You know, I would love to have it on my backlog where that backlog sits out there somewhere. And if I have the time or I am able to worry about the trade-offs, I can go and see what's on the backlog and talk about, is it worth it? Is it more important for me right now to add new capabilities or to do that refactoring and make the code easier to maintain as we go forward? And of course, manage sustainment costs, which is the repercussion of all these trade-offs that might be stuck in the code that we don't know about. Okay. So what we're trying to do with our research is to identify indicators that show me where I have technical debt in the system that may or may not be known about, make it explicit and make it something I can manage as opposed to just something hiding under the surface, you know, kind of biting me when I least expect it. And the way we're doing that is to go through and get real data. You know, we're working with a number of different systems right now where we can look at, and I'll show some examples of this later on, you know, use these indicators, see where we think the debt is, and then go in and test it. So can we find data that says, oh, when you have these indicators, your velocity is going down, or you're having trouble maintaining it. You know, can we find a cause-effect relationship that way that actually has hard data behind it? Okay. So the nice thing about technical debt, well, maybe the not so nice thing, is that most of it is really invisible to the end user. You know, if I have a problem out there in my code that affects how it behaves, well, that's a defect, plain and simple. Okay. So the types of things we're talking about with technical debt are the things that tend to make the software harder to maintain or more fragile, and they don't really rise to the level of letting the user ever know that something's really wrong there. Okay. So on the architecture side, we might have, you know, the kind of architecture bad patterns, pattern violations. You know, I might have a reference architecture, and then I go out and see that no one's actually using it in my development team. You know, these types of things would fall into there. You know, just kind of overly complex architectures that I really should have gone and refactored at some point to make it look more sane. And all these types of indicators have an effect, a visible effect on my ability to add new features, right? I mean, the harder the architecture is for me to get in and add new, you know, to modify, the harder it will be for me to add the new features, add the functionality over time that the system needs to incorporate. Okay. And on the other hand, we also have code technical debt. You know, things like just bad code quality, overly complex code. If you're familiar with Martin Fowler's code smells, you know, the idea that something just looks off in this code, even though I can't quite put my finger on it necessarily. You know, and at the very simplistic level, just coding style violations, where I've gone in and made the code look so ucky and so hard to comprehend that other people are going to have a hard time when they come to it. And those things tend to represent themselves as defects. You know, the more abstruse the code is, the poorer the code quality, the more defects are probably lurking out there that I'm just not aware of yet. And of course, bad performance, bad availability, you know, any number of isms that actually do become visible to the customer at that point. Okay? So by looking at technical debt indicators, we're looking at things that impact evolvability, impact maintainability, but are really invisible to the end user here. And then, like I said, if you look at the research literature, what people have done is kind of jumped on this metaphor. So there's, you know, not only can you find research that looks at architecture and code quality, technical debt, I should say, but there's also this notion of process debt. You know, my processes aren't all that they should be, security debt, and so on. So the metaphor has been kind of strained to the breaking point a little bit. And to keep ourselves sane, what we've done is create a definition of technical debt where we can say, well, we're going to focus in on the software design issues, really. Okay. A lot of the low-level code quality issues do tend to manifest themselves as defects, and they're much more easy to get our hands around. Okay. But as you'll see in a few minutes, when people talk about what technical debt they have on their real projects, it's often the architecture and the design indicators that we point to as being harder to get traction on. Okay. So we're going to focus on that. It's something that has to be traceable to an executable system artifact. Okay. So it might show up in the code. It might show up in my test suites and my build scripts. So we're going to put all these things as fair game, okay, in terms of technical debt that we care about. It tends to be things that can be traced to several locations in the system. So again, if it's just one line of code that's messy, that tends to look more like a defect to us than a technical debt instance. So these tend to be just badly structured code, or code where I've kind of got some kind of misconception and it shows up in many different places in the code base I've touched. And then this all might be true, but if it doesn't have any kind of a quantifiable impact on what developers are actually doing, it's hard to get too interested in it, right? So at the end of this, what we say is that these things that we care about have to have some kind of external impact. And the ones that we go to the most often are things like an increasing number of defects. So as I let my code get more and more kludgy and more clumsily put together, it's harder to understand the logic. New people come to it and don't understand all the intuitions, and so they start making bad fixes and so on. So we see the number of defects often goes up. Most of the time, we're really focusing on maintainability and velocity. So the more of these shortcuts I let accumulate in my code without ever going back and fixing them, the harder and harder it is to make each successive change of the system. I never put that time in investing to make it an easy-to-change system, and so my velocity goes down over time, and I start spending more time trying to figure out all the kludges than actually putting new functionality in. And then finally, we could look at things like decreasing code quality indicators, just indicators of bad code. As I take more and more of these shortcuts, complexities through the roof, cohesion and coupling are going in bad places, and so on. So the thing that we tend to look at varies from team to team, depending on what they care about the most as the external indicators. But we do have a suite of choices here that we can look at when we care about managing this and what the impact on the team is. And I'll go kind of quickly through this. One of the things, it's often amazing to me because we give talks about technical debt so many times, and it's like if there's 3 different people in the room, we'll get 4 different interpretations of what technical debt actually is. So one of the common things that we hear back, which makes us cringe a little bit, is, oh, well, you're just talking about defect prediction. We've already done a lot of that. The defect prediction to us is a completely different set. And again, we're not looking for externally. A defect is something that has an immediate impact on the behavior of the product, right? That the user can actually see. And so those are already handled. We know how to handle defects. Might not always do it as well as we should, but we kind of understand the processes and how to find it. It's a number of static analyzers that will give you more defects than you ever know what to do with, if you're looking for things to do. Technical debt, on the other hand, is, like I said, something that needs to be invisible to the user, okay? But something that's felt in the form of future additional costs. And again, another one of our quotes from the survey, if we're talking about defects, it's very easy for the developers and the managers to have that conversation, because every manager understands what it means that my code isn't actually performing the way it's supposed to. But if you put yourselves in the shoes of the developer trying to have that conversation with management, what we're talking about now is give me the resources to go back and refactor my code. Okay. How much harder of a discussion is that to have, right? Because the manager typically is focused on the external, how happy is my customer going to be? Well, refactoring the code is not going to make that customer any more happy, okay? Unless they're carefully tracking what our velocity is and how quickly we can deliver new capabilities. Okay, so what we're trying to do with technical debt is arm the developers with that kind of ammunition they need to go have the discussion, to be able to talk about, well, all these kludges that we've never been able to go back and fix, they're having this or that bad effect. They're making our velocity go down. We're not able to deliver new capabilities to the customer. And therefore, it's worth it to give us some money to invest in a refactoring because it will have these beneficial effects later on. Okay. And I'll go a little bit faster here. But the idea, of course, being that we can't lose sight of the metaphor. So just because I know where my debt is, that's only part of the problem. I also have to be thinking about, well, what is the interest rate? What are those bad things? What are the bad effects I'm having by having the technical debt out there? And as we'll see later on, if I can't put my finger on any bad effects, well, then I have plenty of other things to worry about. Let's not get ourselves spun up about technical debt. Okay. And then finally, what is the payback strategy? So every time I say, well, I'm just going to take this shortcut. I'm just going to do this because it's good enough to ship. Do I ever foresee a day when I'm going to go back and pay that back? When I'm going to actually go get the resources to make that fix, to do that refactoring, or is this just going to sit around in the system and cause me pain until the end of time? So let me kind of quickly go through this. I'm actually a little bit further behind where I wanted to be. Again, to make it a little bit more formal, what we have is this notion that I probably unintentionally, or intentionally perhaps, take on debt at time 1. I start to see the symptoms of it at time 2. So I might not have realized I did something bad until later I start to see that it's harder to maintain this part of the code. At some point, there's an optimal time to do the rework before the bad things I'm seeing are kind of overwhelming me. And at 4, I have a time where I do pay the thing back. I get rid of that, I do the refactoring, or I get rid of the kludge, and therefore I can move on and start delivering with higher velocity again. Okay. So in a perfect system, 1 and 2 are pretty much the same time. I take on technical debt and I know about it and I put it on my backlog in some way. And 3 and 4 should be at the same time. And the further apart they are, the worse of a job I'm doing in managing technical debt, and the more the bad effects here at time TJ are causing me grief. So I'm delivering less often, let's say. Okay. What we'd like to do is to get to a point where it's intentional and strategic. That I know that I'm taking this debt on, that we make a conscious decision to take a shortcut because there's some short-term benefit that I want, and I put it on the backlog so I don't forget to come back and make it up later on. Okay. And so just to kind of say, there's a lot of different pieces of this problem. If I'm worried about what is my debt, again, we'd like to get, in some of the experiments we're doing now, are trying to get people to record the debt as they take it on. So what are the things I need to write down? One of the difficulties is that when I take it on, I have to estimate the interest, right? I have to estimate how painful it's going to be to me in the long run to take this particular shortcut. And as developers, I think we're notoriously bad at doing that. So how do I go back and revisit that estimate and make sure that it becomes more sane over time, perhaps? The other thing that I can do is just kind of tie this in with my usual risk analysis process that goes on. So especially for longer lived systems, that have more mission criticality or safety criticality to them, we're often kind of revisiting what are our risks for the system. What are my chances I'm not going to be able to deliver on time? And starting to roll in some of my technical debt indicators into that discussion tends to be a very productive way of getting them up there front and center and being able to deal with them. Looking at how debt accumulates over time, there's a lot of different static and architectural analysis tools out there that I can pick off the shelf if I'm willing to come up and see what they give me. But one of the things that we often find is these tools, so CAST is one, Squale is another, they come kind of preloaded with a bazillion different rules in them. So it's kind of their best guess as to all the different ways technical debt might manifest itself. And just like a lot of the other static analysis tools that are out there, if I run these tools, it gives me a long list of here's all the things, here's all the shortcuts I took, here's all the bad things I did that I have to go back and fix now. And that tends not to be so useful for developers. It's just overwhelming, is our point. And so as I'll show you in a few minutes, what we tend to do is to say start small. Let's just pick a few rules. Let's just pick the top things I care about. What are the technical debt indicators that are going to be most painful for me? And let's go write up rules that'll go find those in my code base and just deal with them in the small. So I always call it kind of artisanally crafted technical debt rules, as opposed to the, something like Squale that's going to give me 1,000 rules off the shelf. Okay. And then the question of when to pay back the debt is not one that I'm going to talk about today, but there is some work, and I can point you to it at the SEI, where we talk about how to roll in a little bit of technical debt payback into every of the iterations that I do as I build the system. So again, let me give you just a quick sense from the survey. And what we did here is we looked at 2 defense contractors, given just who we are at SEI, as well as 2 large global companies. Okay, so we talked to, or we sent questionnaires, I should say, to over 1,800 people. And we were looking for answering research questions like, well, when people talk about technical debt, more and more people are doing it. Do we all mean the same thing when we're out there talking about it? Where does the technical debt? What are the best indicators? I guess I should say it that way. And being at the SEI, we tend to think that architectural issues are among some of the bigger indicators. So let's go see if that's actually true or not. And then finally, what are people doing today? The more customers that we work with, the more that we see people are already kind of informally handling technical debt. So a lot of teams, even if they're only doing it in an Excel sheet, will have a list of, here's our technical debt backlog. Which is wonderful, because if nothing else, at least it gives me a way to say, well, here's all the shortcuts I've taken. I want to not forget about them. I want to, as I get resources, go back and try and fix them up. But are there better tools? Are people using these static analysis tools like CAST and Squale and finding a lot more of the indicators? Is that something beneficial to people? And I won't belabor the point. Just to say some of our demographics here, these tended to be fairly experienced developers working on large systems. So the smallest one we looked at was 100K lock, I guess. So these aren't trivial, up to 1 million lines of code in size. So these are, fairly realistic development environments here. I should say they were real development environments. Okay, so the first, what we've done here is just to kind of say the further to the right the bar is, the more respondents we had that agreed with the statement on the left. Okay, so it's a quick way to read it. And we just wanted to get a sense of developers' perceptions, of technical debt. So is it something real? Most of the survey respondents actually were aware of the term, felt that lack of awareness was a problem, felt that it could be used strategically, that it does impact. And interestingly, we had the question on there, do you think that technical debt is just a metaphor? And you see that's the one where most people tended to disagree with that one. So I think when you look at the developer community, these articles about technical debt resonate for a good reason. I mean, there's a lot of people out there where this does describe a lot of the things they run into in their day-to-day work. And we are, I think, hungry as a community for better ways of managing it. And as I said before, one of the things I find most powerful about technical debt is just as a way of convincing the project managers and other stakeholders on the value proposition of managing the debt. So many of the managers I've talked to say, well, developers want to always think everything to be perfect. They always want to go back and do that refactoring. They want to muck about with the internals of the code and make it look perfect, but it doesn't deliver value for the customer. And in the short term, that's hard to argue with. But again, one of the nice things about the technical debt metaphor is now I have a way of articulating some of the longer term costs. This actually, the more bad code we let build up, or the worse architectural decisions we let accumulate in our system and never fix them, it will have an impact on the customer, because I can't deliver functionality as quickly, as cheaply anymore. The velocity at which I can turn around customer requests is going to go down, and they're going to start to notice that. Okay, so it allows us finally to put a dollar figure on some of these things I think as developers, I won't extrapolate too far, that I've always wanted to do and just never had a way to, to convincingly get management to give me the resources. One of the other questions we asked, and we asked this in two different ways, but we kind of said, what are the indicators out there of technical debt? So when we talk about technical debt, what does it you mean as things in the code that represent shortcuts or kludges? And the two different charts here, this represents kind of an open-ended question that they could just kind of type whatever answer they wanted into. And then we went through and looked for patterns and categorized the answers and kind of did a much more defensible research analysis on it. And this was one where they were given a long list of choices, which are here, and they were just asked to pick your top 3 indicators of technical debt and what it means to you. The only commonality I wanted to point out between the two charts is that the first one is always architecture. And you can see architecture gets many more responses than anything else on the list, whichever way we slice it. Whether they responded architecture directly to our question or whether we went through and kind of coded up their answers and put them in different buckets for them. Okay, so from this we take away that there is agreement that architecture choices are key sources of debt. That if I'm looking at the architecture level, that's really want to get a handle on what these shortcuts look like and what are some of the resources I want to get to go fix up the internals of the code. Okay. And then again, just some quotes from the survey to give you a sense of things that we could have done right at an earlier stage. If only we had the time and the money at the upfront stages of the project, I could have done this right. And now we're kind of paying the cost for not having done that. Okay, so was this a bad project management decision? Well, probably not. We were in a resource-constrained environment. We got something done. We got something delivered. That's probably the best I could have done at that point. But let's just not forget that now we have a system that's not going to be as extensible, or that's not going to work with these new technologies in the way that we want it to be. Similarly, we worked on a platform and it wasn't designed with scalability in mind. We got the job done at the time, and now that we need to scale it up to more users, now we're in a much worse position. Did I make the wrong decision early on? Well, probably not. That might have been the best I could do at the time, but we have to understand now that there's these hidden costs, because later on, if I am successful and I do need to scale it up to users, I do have to go back and pay off that debt. I have to give it a better architecture. I have to re-architect parts of the system that I really just prefer to go in and add new capabilities to. Or, at the time, we just made a bad choice. We thought we understood how people were going to be using the system or where it was going to grow, and it didn't turn out that way. So now we have the messaging communication in the wrong part of the architecture. Well, that's fine. Again, it probably was the best we could have done at the time, but now what are we going to do about it? Okay, there's a hidden cost there that we want to make explicit and make sure that we get the resources to go back and pay off. And this slide just says, again, one of the other things that we looked at is the longer the system has lived, the more these architecture issues start to build up. So the older the system, the more likely people were to say that architecture issues were causing them trouble. Okay, which, if you're familiar with it from your classes with things like Manny Lehman and the rules of software evolution, systems tend to degrade over time. I mean, this is the natural course of software. So it's not surprising that we're seeing it there. But again, without an infusion of time and resources, we never get the architecture back up to a level where it becomes better again. We looked at how people track technical debt. So in some cases it was an implicit part of their backlog. I think that's actually one of the better practices out there. Yes, please.
Hi, my name is Bruno. About the architecture, if you let the software development decide that, they're always refactoring the architecture. I have some experience.
Yeah.
So, and when you see here, it's like 80% 3-year-old software compared to 89 for 6-year-old.
Yeah.
Maybe, I don't know, should we take the software into the 6th year to change the architecture? So, I know it's really important, but it makes refactoring all the time. Maybe it's a bad decision also.
I think absolutely. You're absolutely right, and I think that's why. I mean, all this was trying to say is that the longer it sits out there without refactoring, the more architecture problems I'm going to have. So that's really all that we're trying to say here. The point you're making is exactly the right one, though. I mean, the answer is not to retire technical debt all the time. So it's not every time I take a shortcut I fix it immediately. That's the wrong answer too, clearly. And so it's trying to find out what is that middle stage, where I can let these things sit out there for a while because it's doing me the short-term benefit of letting me deliver on time, or getting that next release in front of the customer. But at the same time, the longer I do leave it there, the worse that architecture is, and it's going to cause me no end of pain as I try to make each successive change to it. So we don't have the magic answer to that. I mean, I can show you some of the indicators that we've used, and in a particular context, it seems to work well. But I think that's the best answer we can say is, what we're looking for is a way to visualize how much pain it is causing me at the moment. And then I have to make my own choices about how much is too much. But I'm thankful for you that you put such a fine point on it, because exactly, we're not saying that you always pay it off either, because then that negates all the benefits of, well, it was helping me deliver on time, or there was a reason for taking the debt on in the first place. Okay. Thank you. And I should say too, I've been talking so quickly. I already know what I'm going to say, so it's actually much more interesting to me if people do ask questions and we have more of a conversation about it. So please feel free to to speak up and give me some questions. Anyway, just a couple last points to make. How do I track it? Some people are putting it on the backlog. I think that's wonderful, because it makes sure that I don't lose track of it. It sits out there just like any other defect, and it makes it a first-class citizen. Another practice I think is great is we see people doing retrospectives. So I do stop, maybe not with every release, but at certain points in the problem, at certain points in the project, and kind of look back at what's gone wrong, what's gone right, what do we think the quality of the code really is. And that's a great time for resurfacing some of these things. Geez, I really think it is time that we took some time to refactor the code, or things are starting to get a little crusty, but overall we're able to deliver. So I think taking the time, even if it's just for an hour, a meeting periodically, to kind of look back and think of what the developers think of their own quality on the project is a very helpful thing. And then where do I track it? We look and most people are tracking it at the team level if I'm doing anything, some a little bit higher. In 6% of cases, it was actually being tracked at the company level, which I find somewhat unusual. I've talked to a lot of places, kind of the Lockheed Martins and the larger companies of the world that had this idea of kind of instantiating a cross-project databases that look at where the root causes are and what some of these technical data indicators are. But I find the context from project to project so different that I haven't really seen much value in those myself. But the most what most people are doing is really no standardized approach at all. So yes. Okay.
Marina Levy, and I'm teaching here in software management program. I would like to know if you have data of technical debt attributes and differences between startups, middle-sized company, and larger company.
That's a great question, and I don't actually.
Especially for the Silicon Valley.
Yes, no, I would love to get a handle on that. I really would, and I don't have that data, but let's talk actually and see if there's a way we could go get it, because I would love that.
I used to work for MITRE, by the way.
Oh, did you? Okay, excellent. So you're more familiar with the kind of the DoD life cycle that we put earlier, which is no. Yeah, please. Yeah.
In the startup world, where agile technologies and methods and stuff like that, I have the feeling my hypothesis is, listen to it, students, is that there is absolutely no awareness of technical debts, and you just go, do MVPs, okay, and God knows what happens later. So that's why I'm interested in it.
I would love to know that. I would tend to think that's probably true, but at the same time, I've worked in startups before too, actually, and and we on the development team always did have that same pressure to management. We didn't always get the resources, I need to say, but we often said, "Oh my God, we've been kind of killing ourselves trying to get this thing delivered, but oh my gosh, now we need to take some time and go refactor it. I mean, it's become a mess, and it was very difficult to make that argument. I would love to get the data, that might help some developers win the battle.
But paradoxically, it also emerged from the agile community, the concept itself. So they certainly are, if they have any knowledge of agile history and its underlying concepts, they would be familiar with the term. Whether they're just giving it lip service or not is a question, actually.
Well, and the reason that it resonates so well in an agile environment is, as I do multiple iterations, I have a chance to measure now across what might be normal sized chunks of the project, and I can see on a much more visceral level, is my velocity really going down? Is it taking me longer and longer to put in what I think should be about the same unit of functionality? And that's the only time that management, in my experience, at a startup ever does say, okay, let's take the time to go refactor it now and kind of put it back together in a more sane way. But no, I would love to replicate the survey with Silicon Valley folks. So let's talk about that after. Great. And a few other things. What we do see are, if anyone's using any tools, and some of what we do to track technical debt is really just social processes. Some people are putting code rule checkers and other code, looking for code metrics out there. Tend to be a small minority of the people in our survey. If anyone's doing anything, what they are is doing is putting it on the issue tracker and at least keeping track of it, so I don't forget about the shortcuts that are out there. Okay. And I should say too that people can do more than one thing. So the numbers here add up to more than 100% if I add in the 58% that aren't doing anything at all. And this is what we would like to fix. I mean, this is, I think, there's ways, even if I just simply put it on my issue tracker, I'm already so far ahead of where I was before that it's becoming a better thing. Okay. So where this was, to our knowledge, it's the first of its kind in terms of being a broad-based industry study. Technical debt research is only probably 6 years old, really, and this suggests that there's gaps in the current research, that we could be providing better tools for people in the real workforce to manage these things, and we're just not getting that out there. And despite the fact that researchers now seem to want to tag everything in the world as technical debt because it's a sexy term, it really does clarify that on the developer side of things, people resonate with the term. They find it useful to get a handle on what they're doing on a day-to-day basis. And I think there's impacts that we could have there. So if you're interested in the full results, this was a paper at FSC a couple of weeks ago, and actually I managed to get an award for that. But where I wanted to end up with is our vision for what we're building in terms of tool support. Because from my point of view, again, as a data guy, I think that what we have in almost any software development project is a rich wealth of data that actually allows the team, if only we could exploit it to get our arms around the technical debt, excuse me. And kind of by nature of this broad term, I've been talking in generalities, I know, for most of the beginning of the course, but of this talk, but there's so much more we can do. The process that we're going to, and this is actually something that predates my time at SEI, so I've kind of brought this with me from Fraunhofer, but we've worked with a number of companies and kind of walked through the same type of similar process. Like I said, step number one is define what we're calling non-conformance rules. So rather than kind of say, here's 1,000 different ways, here's 1,000 different rules that will go to capture technical debt, what I would much rather do is have a conversation with each project and say, when you talk about quality, what do you think the most important thing is? And if you're breaking those rules about good quality, how would you even detect it? And that gives us a hypothesis, as you said, about what bad quality or technical debt looks like in that context. Okay. What we then go is turn that rule into something that's metrics-based, so that we have, even if it's not perfect, we have a way to kind of run through our code base and go find out, where am I breaking my own rules? Okay. And what that requires me to do is to have tools that can go out and look at my code repository, go out and look at my change in defect tracker, because the other thing I want to know is for each piece of code, how likely was it to have changes or defects in it, because these are indicators that I might have technical debt building up. And what other repositories or what other pieces of information do I have? And what we've been doing is trying to build tools that brings this all together so that this is now a semi-automated step instead of a long process in analysis. Okay. The step here that says judge risks now means let me go back and look and see where I'm breaking the rules and are there bad things happening. Okay. Because what we find is that developers tend to have lousy intuition, actually, as to what quality rules mean. We have a lot of teams that we've worked with, they come up with all kinds of rules about reference architectures and code styles and all the rest of it. And then what you find out is when people break the rules, it doesn't really hurt them too much. Okay, so let's go out and test that. Like I said, I like to come up with these rules and call them hypotheses, because they're in a sense my intuition about what quality means for me. Let's actually go out and test it and then see if they're actually detecting things where I'm feeling pain on the project. If so, let's go out and implement project changes, because now I have a way to automatically detect where I might have technical debt building up. And if not, well, let's throw these out and find better rules. There's a million things I could worry about. Let's at least pick the ones that are actually going to cause me some real pain, when I'm worried about tracking them. Okay. So this was a case study with a small-sized company, IT development. They were doing a number of different web applications. Actually, this was a rare instance of a small company that was, if you're familiar with the CMMI process maturity levels in software, it was a level 5 company. So they had fairly mature processes in place. Their business goal was reducing the amount of money that they spent on maintenance. So if we talk about a GQM now, here was the overriding goal here now was get a handle on software maintenance costs. Now how do I reduce that over time? They had a hypothesized strategy. So again, this was what made the most sense to them in terms of a quality goal. How were they trying to get a handle on it? Well, they had a two-pronged strategy. Okay. One was have all their projects use a common reference architecture. So they could say, anytime I pick one developer up and drop him or her on another project, they should recognize where they are and understand the major pieces of the system because they're all following the reference architecture. And then secondly, they should be refactoring frequently. Okay, so there's time actually in the schedule, at least the managers felt, for the refactoring to happen. So we shouldn't be seeing a lot of these architectural shortcuts building up. Okay. And then, of course, every version of their software was checked into the code repositories. They were very good, actually, about tracking defects and changes and tracing them back to components. So we had a really nice data set to analyze. Okay. And then I should have said, too, what we then took was their intuition about how to get a handle on quality and turn that into rules. Okay. So their reference architecture was easy enough to detect. I mean, it was very custom, but they said, if this layer should never talk to that layer, so now we can go out and look for connections between the two. Their intuition about refactoring frequently, we said, well, how do we indicate that? Well, if I'm refactoring frequently, one thing I should not have is, again, going back to Martin Fowler, I shouldn't have too many God classes. So a God class in Fowler's terminology is a class that's trying to do everything, and therefore is hard to maintain, hard to comprehend, and so on. And one of the things we found out in the literature was at least a fairly decent starting point about a set of metrics that would help me indicate God classes. So we coded that up in our tooling, ran through the code repository. And what I'm showing here is the way we visualized the results. So this was kind of just a subset of the lifetime of the project. Each row here is one component. that was in the code repository. So you can see those components kind of have a birth date, and some of them have an end date where they get refactored out of existence or deleted for other reasons. Every vertical line is a check-in. And if it's coded red, that means they were breaking the rules. So a guide class existed in this component from June 2009 onwards. Okay. So it was a way to kind of now visualize back to them the intuition of, am I breaking my own rules? And then what's not shown here, but what we were then able to do, because they were tracking changes in defects, was, well, do I see that change do I see that when a component is red, essentially they were breaking their rule, that it's more change prone or more defect prone? And in this case, the guide classes, in fact, were. I think I have those results here. Right. So let's go back and test it statistically. Well, we can look at how often it's likely that a change impacts a guide class versus a non-guide class. I didn't show the data here, but we can then normalize this for lines of code, just to make sure that we're not just saying that the classes with more lines of code change more often. That's not what was happening, actually. But the guide classes were 5 to 7 times more change prone. So when I broke my rule and didn't refactor these things out of existence, I was actually having to change them all the time. So they were becoming change bottlenecks. And then similarly, are they more defect prone? Well, we did the same type of analysis. And the guide classes were 4 to 17 times more defect prone, again, after I had already normalized it for the lines of code. So in the interest of time, in the few minutes I have left, I won't go through all the analysis, but essentially, do we find any hard quantitative data when they broke those rules that there was a bad effect? Well, actually we do. Okay, so this was something that we were able to put in place with the company. And now as they go forward, they continually run the rules and scan for where these guide classes come. And they know that it's worth it to get the effort to refactor them and get the architecture better before they build up and start to cause me pain again. What's interestingly is when I mentioned that idea that developers sometimes have bad intuition, what we found was then when they broke the rules about their common reference architecture, there was no bad effect there whatsoever. Okay, so whether they followed it or not, it didn't seem to have any impact on how liable those areas were to be change prone or defect prone or their velocity to go down. So those were things that we asked them to think about phasing out over time because it wasn't really worth the effort. Okay, so in the end, kind of the vision for where we'd like to go, what we have in the blue arc here is kind of, you notice what we're looking at is the value over time. So what's the value my development team can deliver per unit time as I'm going through and doing iterations and delivering new capabilities. If I let technical debt build up, then essentially that curve starts to bend down. So that I get to an optimal point where I'm releasing things on time, but I'm letting all those shortcuts build up. And then as things go forward, it's harder and harder to make every change. It's harder to comprehend the code because I never went back and cleaned it up. And so as I said, it starts to become finally visible to the user in the sense that the capabilities I can deliver per unit time start to bend down, and I'm not being as productive and responsive to them anymore. By effectively managing technical debt, what we'd like to do is get closer to that yellow arc, where we can continue to work at the same velocity over time, with some notion of refactoring buried in there as an investment that I'm continually paying back on the interest I might have taken out. And then, as I said, it's an interesting research project, and there's a lot of data that we're putting against it, and results that stand up to scientific rigor. But the nice thing about technical debt is it's also something that seems useful to developers on a day-to-day basis. And so some of the practices that we see being incorporated fairly well into ongoing projects, using some kind of visualization tool that doesn't have to be the prototype I showed a couple slides ago, but just ways to make the architecture features visible, visualize where I'm breaking my own rules about quality, and then start to reason about, is that something I need to be taking corrective action against? Trying to differentiate strategic structural technical debt. So where am I really making a shortcut because it's going to buy me something in the short term from those indicators where I'm just being a little sloppy, where I'm not doing the due diligence to make the code as clean as it should be. Investing in some kind of tools and techniques to help elicit leading indicators. Like I said, there's tools out there. I think it's Squale is free for download. At least there's a demo version of it. So if you'd like to go out, like I said, there's a large number of rules in there, and you can turn some of them off. But at least gives you something to play with if you're interested in starting to experiment.
SonarQube also.
SonarQube, thank you. That was the other one. That might be in a class project or something. It seems like. Right, and as I said, I always like to start small. So think about what it really means to me, and if I'm only tracking 2 or 3 rules that mean something to me, then I think I get more value out of that than tracking 1,000 rules that somebody else said might be relevant. Technical debt gives me a way to engage the business and the technical persons in making these trade-offs. So we have a way of now talking about everything kind of reduced to a dollar figure, for better or for worse, or to effort and things that become visible to the customer and what that might be doing to the overall project. But those trade-offs actually need the other perspective there. So as a developer, like I said, I do have a tendency to make everything want to be perfect. I want to go back and do the refactoring, but it is worth it to have that conversation now about, well, what are the long-term impacts? Is it really buying me anything to go back and do that refactoring? To the extent that I can pull these things into standard operating procedures, the better. What we find always is that if technical debt discussions become a special thing off on the side, then they go away over time, just like anything else. So if I can pull it into my planning stages, if I can pull it into my code reviews, or into my retrospectives that I do periodically, and start to ask, what do we think technical debt looks like on this project, then I get a much better result and keep it institutionalized. Okay. And like I said, what we find, and again, this maybe comes from the MITRE DoD-ish kind of perspective, is that looking at technical debt as part of risk management, and what are the overall risks to my project, and will I be able to deliver on time? Do we start to pull some of these issues in there is probably the best place to put them, because it ties into an established process that we already know we have to care about. Okay, so this is a person with a tie, therefore he has no technical credibility. I just put that there. The last thing I would want to do is to say this was all my own work, because this was the outcome of a large team at the SCI, and so I at least wanted to make sure you had all their names here on the end. It's an area that we're continuing to work on and go on with, and so like I said, I would really love to continue the conversation and hear from you all about whether or not you experience technical debt, whether this resonates with you on the day-to-day work that you do, and if you have other ways of thinking about technical debt that we might not have considered yet. So thank you. You've been very patient as I've talked very quickly. So thank you. I hope we have a few minutes for questions. And
yeah, I think we have time, and I'm gonna monitor the chat window on Adobe Connect for questions from online listeners. So do we have any questions from the audience? Let me see if we have any questions online. Somebody was asking about the names of the tools, and I already answered that on the chat window. But I do have a question. So you're talking about this. Well, in the beginning, you emphasized the importance of architecture.
Yes.
And then towards the end, most of the focus was on code smells, kind of on the low-hanging fruit rather than. How do you detect when the architecture is broken? Sometimes you can percolate a code level anti-patterns up to architectural anti-patterns, but that is not always easy or even possible. So what can we do about
that's an excellent
high-level stuff?
Yeah, no, that's perfect. That's actually an area that we're continuing to work on, and we haven't been very happy yet with the tools that we found out there in terms of the architectural type of impact, type of things that they can detect. So as we go forward, that's something that we're trying to build into our own tool set, is trying to be able to reason about it at that level. I think there's always going to be a trade-off there. I mean, the kind of easy go-to places would be to kind of measure the architecture in terms of things like complexity, the cohesion. Is it a spaghetti architecture where everything talks to everything, or is it nicely modularized? But once you get past those kind of fairly trivial first steps, I mean, it's hard to know where to go from there. And so that's one of the areas we're working on, is trying to build up that kind of a pattern library, and then how do I detect that usefully going forward.
I think that would be great. Also, kind of how you can record, I don't know, maybe architectural decisions and then convert them into rules so that you can detect when they're violated. In the beginning, you give an example of, I think it was, right communication mechanisms in the right places in the model view controller, architecture. So like the FSC class has precisely that problem, and we observed that in the past. Kind of they precisely make that mistake, put the wrong kinds of communication mechanisms in the wrong places in the architecture. That's a behavioral architectural pattern. It's very difficult to detect automatically, but. Well, they incur such a big debt as a result of that.
Absolutely. I was going to say, you'll notice that the one architectural example I did give was about a reference architecture. Yeah, so it was kind of defined in context, and we had a way of mapping a given architecture to the reference, and we could look for where those particular rules were broken. But that was not generalizable at all. And so I think that's one of the reasons we've tried to shy away from it a little bit, is that I think there's so much context information. Like you said, what are my architectural decisions that need to go in there? But it's a much harder problem than just dealing with the low-level code stuff. But that's exactly our longer-term place for where we're going to go. Thank you for pointing out that deficiency in our work.
Well, it was not meant to be a criticism, but I mean, maybe future work.
Hi. I think about a company that doesn't measure technical debt at all, but sometimes they say, okay, we have to stop doing what we're doing to fix this. Is there a simple measure that we can show to the management team saying, oh, this is happening?
Yeah.
Like we have 20% of than we should, or do you indicate something to start?
Perfect. The one that I always go to is the velocity. I mean, and it's a little bit difficult because I know that not every capability that I'm going to deliver over time is comparable one to another. But again, as long as I'm doing periodic releases and I can get an estimate of how much capability I'm pushing into each one, I think that becomes the most visible thing, and it's the thing that resonates the most with managers. Again, and just in my experience. Okay. If we can say that, geez, in these, we're trying to deliver every 6 months, for example. Look at how little new capability was in this release versus the earlier ones where we were able to do. And part of that might be that the capabilities just become more sophisticated over time, but a lot of the time it's because the code base is getting so hard to touch, and I don't, going back to that early slide, there's places of it I don't even want to touch anymore because I know that it's working now and it's going to break as soon as I try and do anything. So I think going back to that notion of velocity over time is really the kind of at least our go-to measure, and see if we could get something reasonable there.
And maybe something to anticipate that I don't want to touch that. Like I know that there are 30 things that I did there that I would like to fix.
Well, and so but that gets back into one of the complications of the metaphor is what's the interest I'm paying on it. So if I have 30 fragile places in my code, but I'm never modifying them, that's probably fine. Yeah, that's debt that I don't want to pay back because I'm not paying any interest on it, essentially. So I think it does depend on, if I could point to those places and then say, look, every time we have a change, every iteration, we're going back in and having to deal with those fragile parts of the code. That again might be a more convincing piece of measurement. But just to say that those bad things are out there, I think doesn't, because, well, they might be in a place that's, it's safe, it's compartmentalized, and I'm never going to touch that one again.
Yeah. It's always hard to convince the managers that we need to stop.
Yes. Yeah.
Okay.
More questions? Let me check the chat window. Okay. Well, I have one more. Okay. Do you have any strong views about like architectural reviews with an eye on technical debt? Is this a concept that is being contemplated? I'm not talking about like heavyweight stuff like ATAM or anything like that, but some kind of intellectual practice that is focused at the architectural level, is a little bit more systematic, just on informal reviews, and highlights, emphasizes technical debt.
Yeah. That's an excellent question, actually. I was going to say it ties into the whole, a lot of bigger issues about how do I get people to talk and to do the review in a constructive way, and to talk about the architecture. Yeah. But I think absolutely, I mean, if we're out there getting a lot of eyeballs looking at a particular architecture and seeing if I've made the right decisions, this becomes an important discussion point to bring up. And sometimes, maybe the ulterior motive is sometimes if I call things technical debt, that's less bad than saying where are the defects in this architecture? Yes. Where are the bad things? And so just by changing the terminology, I've made the conversation a little bit more constructive. Yeah, absolutely. And to the extent that a program has architecture reviews already in place, I mean, if I could kind of glom onto that, then it becomes much more likely I actually get to have the conversation about technical debt anyway. Thank you.
I have a question for since if a startup, if they wanted to build a system from the very beginning, so there might be not so many users as a very early stage, but after they scale up, probably there will be like more problems here for the technical debt.
Yeah.
So if they scale up, so if the problems lie in, for example, architecture, how are they going to like solve this problem since it's very crucial for them to change because their architecture already like decided. So maybe there are other suggestions or advice for like how for the startup to scale up in this dealing with this.
That's another excellent question, actually, and I think I mean I do think that having an eye in the beginning stages to what I was going to say when you talk about scale up is I think it's very hard for a startup because in the beginning if I can just work with a small number of users and demonstrate some value, that's what I have to do today. I mean, if I start to build my system with the thought that someday I'm going to have 100,000 users and I need to put all this robust functionality in there, I'm not even going to get off the ground. So I think a large part of it is to make those trade-offs. To make sure that I'm doing something that'll work today, and I understand it's not going to scale up, but at least to start recording what are the fragile points. So that later on when I hopefully will be successful, and I suddenly need to scale up in a small amount of time, I don't have to go back and suddenly rediscover all the trade-offs I made, but I have some kind of a record right there. And and I understand talking about architecture decisions too. This is the kind of thing I think we've been advocating for a long time, and I've never found a good way to do it. But I think at least to make the effort is already better than just kind of letting it go by the wayside and forgetting about the trade-offs we're making in the early stages. So I don't know if that helps, but I can at least say yes, that's a problem.
Oh, you were talking about architecture and technical debt. I actually saw in your research a relationship between the code and technical debt, if I got it right. But do you actually do an architecture to technical debt research? And also, there was a subsection to it. Do you differentiate between database architecture, the logic, and overall system architecture? It's because architecture is not really just one thing.
Right.
You can make great architectural decisions, then you can get shitty code, and so how do you really measure the technical debt based on code, or more than that?
Well, it's more than that. I think it's like I was trying to say to Hakan's question. I think a lot of the architecture things become more context specific. So there's things like at the code level we can talk about guide classes and some of the bad smells like that, and those are going to be true almost of any system I would look at. Guide classes are always going to be bad. It's just a matter of how much I prioritize them. For the architecture, I don't think we've ever found a better solution than let's go in and do that in our architecture analysis, and you tell me specifically in this system, and not in general terms, but just in this system, what should not be talking to each other. And those become now architectural issues I can look for. It's never anything I would generalize. I can say, now I've learned a principle that worked on this system, and I can pick it up and take it to the next one, unfortunately. But at least having that conversation with the people and they're being familiar with their own architecture gives me a sense of what rules I could code up and go look for.
So you're saying like code level issues are more pervasive, and then architecture level stuff is more context specific.
Absolutely. I think bad code tends to be bad code, has been my experience. Whereas architecture, the question is really fitness to the context is what we find a lot of times. Yes.
Hi. So with the evolution of technology, I mean, from an engineering point, if you look at the .NET system from the ASPX views and it evolves as every few years.
Yes.
So do you think that clean code and proper architectural principles help mitigate that transition or help mitigate that technical debt in technology choices?
Oh, absolutely. Absolutely. I mean, it's interesting because you put your finger on one of the discussions we've had kind of internal to the team. When we first started, some of the examples of technical debt that people would say are, I designed my system really well and it worked fine for 3 years, and then the technology changed underneath me, and now suddenly I went from no technical debt to suddenly $1 billion dollars worth of technical debt. And my sense was always, in a way, that's not a fair thing to call technical debt, because I couldn't predict necessarily the world was going to change in that way. So it's not like I did some kind of deficiency in my thinking originally. But the part of it that we can call technical debt is if I design a system with a nice architecture that's easy to understand and clean interfaces, as the technology changes, it's a lot easier for me to plug out pieces and plug in something new. If I have architecture that looks like spaghetti and everything's talking to everything else, then then God help me when that technology changes. So I think scoping it in the right way, but absolutely. I mean, portability and things that I can, sloppinesses that contribute to bad portability, I would put it entirely under the technical debt umbrella, absolutely.
outside. We're going to just wrap up.
Perfect, perfect. Thank you so much.
Thank you
I've
very
really
much
enjoyed this
for
chance.
coming and sharing your results with us. And can we make the slides available?
Oh, absolutely, absolutely.
Please, I think we're going to get a link to the recording posted. And
Sure. And like I did put my email address on there. Like I said, I'm always not the best person to answer email within a day, but I always do love to hear and get indications from different project teams how you define technical debt in your own environment. So if you want to continue the conversation, I'd love to hear from you.